Welcome friends. Today we are going to see some of the important definitions about the terrestrial photogrammetry, and then we are going to derive few of the equations regarding the photogrammetry, especially the terrestrial photogrammetry. Now before going in further, just I would like to brief the thing is that we have started module 4, that is aerial photogrammetry. Now before going to the problems and the getting the things done with the aerial photogrammetry, you should understand the terrestrial photogrammetry and the knowledge of basic photogrammetry. So today we are going to see about the basics of the photogrammetry. Then we'll go for the, in the next coming classes we are going for the aerial photogrammetry. Now a few of the definitions, as now you can see this figure. By understanding this figure you can easily get the definitions. The first definition is camera axis. Now you can see this figure. We are having two planes or two plates, you can call it as. One we called as negative. All you know about the how we supposed to get the photographs. All we know that previously we are supposed to use the negative films to develop the original pictures. Means all you are well aware about the camera company called Kodak, and you are used to suppose the reel for that. Then put that reel there and then take a negatives, then develop those negatives into the original photographs or the pictures. The same concept will be here. You can see that you'll be having a camera plate. This is the camera plate that we called as negative, right? And then you will be having a picture plane, or you can call it as what, developed photograph here, that we call as positive or picture plane. Now to get the image of this object, now if you are having an object, see this object, if you are having an object a dash, and if you want to get that on the picture and you want to develop an original fill for that, now how it will be, see this a dash, it is going to be no, here it is going to be, here it is a dash or a1 I have shown here. Now that a1 it is going to be reverse here. Now here you can see this. Now here you can see that you can see the a properly. Now here that a, it is going to be a dash, and this a1 it is going to be a1 dash, right? It is a negative. Reverse image is going to be here. Then when you develop this negative, you will be getting a proper image. I mean, you can see that a and a dash here in this picture. It is a picture plane, that is a original or positive image you will be having. Now with these two planes, you will be having few of the things that what I want to clear. So first you can see that here you will be having this we call as what, principal plane. Now this you can see this principal plane. Now this principal plane means if you take the fiducial points, in the last class, in the last problem, we all know that what is fiducial point. See, if you are having the points or reference point on the photograph or on the picture like this, and if you join these fiducial points, then we call them as what, principal lines. You'll be having principal lines. Now here this dotted line here, this line, that is a principal line, and here also this is also a principal line. Okay, and where these lines are lying, those we call them as, that plane we call it as what, principal plane. Here also you will be having, see this, these two we call them as what, principal lines. Now this junction or the point, you can see the center point K, right here, that is that is very important. From this point K here, that point is going to be K dash here, and the distance between this, see this, right, K to O. Now this point where these lines are coinciding, or the imaginary lines are coinciding, you can call it as photographic rays are coinciding. So those here, this we call it as, this point is your this is your center point, right, center point. Then you can call it as a prospect center. Then right, see this is O and this is K. The distance between O and K, that we call as what, F, that is your focal length. Similarly here this side also, the distance between K dash and O, that is also your focal length. One more dotted line you can see from K to K, right, from K to K dash, right. So that No, that we call as what? Camera axis. Now this line here, K dash to K, that we call as what? Camera axis. Now with this camera axis, see, you'll be having this we call as what? See, this is a horizon line. This is a horizon line, right? And we'll go one by one, then you'll come to know what are the things are there. First definition is about, we are talking about the camera axis. Camera axis is the line passing through the center of camera lens and perpendicular both to the camera plate and picture plane. That is, camera plate means negative and photographic positive. So the line, see this dotted line K dash, that we call as what? Camera axis, which is perpendicular to the picture plane and camera plane. Then you will be having the picture plane. What is picture plane? Picture plane is the plane perpendicular to the camera axis at the front of lens. It is represented by the positive contact print or photographs on the plate or film. Now this is your picture plane, which is perpendicular to the camera axis. Now here, principal point, as I said that K and K dash are lies at the center of principal lines. When the principal lines are crossed here, so that the center, the crossing point will be your principal point, as I have shown in the figure. The principal point K and K dash is defined by the intersection of camera axis with either the picture plane, that we call as positive, or the camera plate, that we call as a negative. Focal length, that is the distance from O to K dash. Focal length is the perpendicular distance from center of camera lens to either picture plane or the camera plate. I'll show that. Now here, these points here, you'll be having K and K dash, principal points. Then you'll be having the focal length. See this, from O to here, this distance will be your focal length. Then focal plane, or you can call it as image plane. Focal plane is the plane perpendicular to the axis of lens in which image of point in the object space of the lens are focused. Then nodal point. Nodal point is either of 2 points of the optical axis of a lens or a system of a lens so located that when all object distances are measured from one point and all images distance are measured from the other. Then the prospective center, it is the point of origin or termination of bundles of prospective rays, that we call as what? Prospective center. Now that O point, as I said, that is the prospective center. Principal distance, when the contact points from the original negatives are enlarged or reduced before their use in the compilation of subsequent maps, the value of focal length f of the camera is not applicable to the revised prints. The changed value of same geometrical relations is known as the principal distance. Principal plane, the principal plane is the plane which contains principal lines and the optical axis. Where the optical axis and the principal line lies, that we call as what? Principal plane. Therefore, perpendicular to the picture plane and the camera axis. Principal plane will be always perpendicular to the picture plane and the camera axis. Then 10th definition is about print. A print is the photographic copy made by projection or contact printing from a photographic negative or from a transparent drawing as a blueprint, that we call as what? Print. Then fiducial marks, all we know that previous class also I have told about the fiducial marks. We call them as reference points for the photogrammetry. A fiducial mark is one of 2, 3 or 4 marks located in a contact with the photographic emulsion in a camera image plane to provide a reference line or line for the plate measurement of image. I'll show that. Now here, if you take these points as a reference points, right, then we call them as what? Fiducial points. These are the fiducial points. You got this? Fiducial marks, we call them as what? Fiducial marks. Now 12th definition is a fiducial axis. As I said that we know what is the fiducial point. Now if you take a camera plane or a photographic plane, and if you mark the reference points to that, and if you join those reference points, then we call them as what? Fiducial axis. The line joining the fiducial points, we call them as what? Fiducial axis. Opposite fiducial mark define a reference line. Two pairs of opposite fiducial marks define two reference lines that intersect at 90 degrees. These two lines are referred as x and y axis or fiducial axis. Now here see, these are the fiducial marks, and if you join these fiducial marks, you will be having fiducial axis, right? Or you can call it as x and y axis. Now those axes are very important. As we go further, you are going to come to get those axes into the calculation, so that we can easily simplify the distance measuring on the photograph. And then the last definition is film base. Film base is a thin, flexible, transparent sheet of cellulose nitrate, cellulose acetate, or the similar material, which is coated with a light sensitive emulsion and used for taking the photographs. Now by using those definitions, now we are going to derive a few of the derivation. The first derivation is horizontal and vertical angle from the terrestrial photograph. Now you are going to locate the image. See, this is A point and this is B point. You are supposed to locate these 2 points on the photograph, and you are supposed to measure the horizontal and vertical angles of these points from the prospective center. 2 points A and B photographed with a camera axis horizontal, so that the picture plane is vertical and the horizon line is horizontal. The image of ground points A and B appears at A and B, small a and small b respectively, and their projections on horizon line at A dash and B dash. Now you can see this A and B. This A, it is going to be, see here, it is going to be small a, this point, and this B is going to be, see this B, it is going to be small b here, right? So in similarly, their projection on horizon line, see on horizon line it is A dash, right? Here I have shown it is A dash, and on horizon line it is B dash, right? Now before going further, just I'll clarify, as already I have said here, this projection of A, and this is as A dash, this is B, and this is as B dash. Then you will be having the vertical and horizontal angle. Now this is alpha A and alpha B are the horizontal angles with respect to the camera axis. See, this is O and K is the camera axis, right? And the distance between O and K, here I have shown it as focal length F, and beta are the vertical angles, beta A and beta B, 2 vertical angles and 2 horizontal angles. Now same projections I have shown here. Now you can see that here you will be having see from A to A dash, you can call it as XA, that is with respect to this principal line, and A dash, that is YA, right? Sorry, I said it as reverse one, right? So from the principal line, see from this principal line, the distance of A is XA, and from this horizon line, right, this distance is YA. Okay. Similarly, with respect to this B also, see this distance of B with respect to this line, that is XB, and here also the distance between B and B dash, or distance between B and with this horizon line, that we called as what? YB. Here I have shown YB. The same projection you can lay in this direction, so that you can easily analyze the things, right? This is the plane, right? Central plane here. Then this is the point K, and this is O. This is F here, distance between O and K. then you can see that this is A, this is B, and here you will be having A dash, here you will be having B dash, right? This is K1, this is K2, and this is K, right? So we are going to derive the equations by using these two figures, this and this. If small f, that is OK, is a focal length of the lens, the horizontal angle alpha A and alpha B are given as, see that horizontal angle alpha A and alpha B. Here tan alpha A is equal to tan of angle, see that A dash OK, A dash OK. Now I will show you, see this is A dash O and K. So it is the angle, this angle they are going to consider now, this angle, right? A dash O and K. Now with this angle, see that tan alpha A, here this is tan alpha A, this tan alpha A is equal to XA divided by F, right? This distance is XA, right? This distance is XA, and here it is, you are having F, right? So that is going to be tan alpha A, XA divided by F, and tan alpha B, right? Tan alpha B, see, if you are supposed to take the angle this B dash O and that is B dash O and K, this angle you are supposed to take, right? This is B dash O and K, this angle you are supposed to take, B dash OK. Now with this tan alpha B, this is tan alpha B, this tan alpha B is equal to, that is XB divided by F, that is XB divided by F, right? So these two are very important formula, horizontal angles, tan alpha A is equal to XA divided by F, tan alpha B is equal to XB divided by F, where XA and XB are the photographic X coordinates of A and B with respect to the principal line as the y-axis. The horizontal angle between A and B is then equal to the alpha A plus alpha B. The angle between A and B, that is total angle, is alpha A plus alpha B, or no, in general you can write alpha A plus or minus alpha B. Similarly, now to get the vertical angles, similarly let beta A and beta B be the vertical angles to A and B, vertical angles to A and B. Now you can take tan beta A is equal to tan of AO A dash, tan AO A dash. So we'll see this into the figure. Now you have to check the angle AO A dash, this triangle you are supposed to check, we'll see that. Now here you are supposed to take, see this, to get this beta A, you are supposed to take the angle, this A dash O A, this triangle you are supposed to take. Similarly, to get this beta B, which triangle you are supposed to take? You are supposed to take the triangle, see this B dash O and B, this triangle you are supposed to take. Now vertical angles beta A and beta B, see here beta A is equal to tan of AO A dash, that is AA dash divided by OA dash. Now where AA dash is YA and OA dash is F sec alpha A. Now here you can see that AA dash is equal to YA and A dash O, this line is, see that is F sec alpha A, F sec alpha A. Similarly here also see this BB dash is YB, and when it is going to be OB dash, it is going to be F sec alpha B, right? This is F sec alpha B. Now as AA dash is YA and OA dash is F sec alpha A, then tan beta A is equal to YA divided by F sec alpha A. Similarly, now here tan beta B is equal to, see that BB dash divided by OB. As I said that BB dash is YB and OB dash is F sec alpha b. Then tan bb dash is equal to yb divided by f sec alpha b. Now all those things I have summarized here. You can see that horizontal angle tan alpha a is equal to xa by f, that is tan alpha a is equal to tan inverse of xa by f. Tan alpha b is equal to xb by f, that is tan alpha b is equal to tan inverse of xb by f. Similarly, vertical angles you can see here, tan beta a is equal to ya divided by f sec alpha a, that is beta a is equal to tan inverse of ya divided by f sec alpha a. Similarly, tan beta b is equal to yb divided by f sec alpha b, that is beta b is equal to tan inverse of yb divided by f sec alpha b. Now this is what the derivation, this is first derivation. You have to remember these important formulas. Now one more important thing that we are going to discuss about the azimuth, right? Camera azimuth and the particular points azimuth, objects azimuth is very important. Now before that, you just go with the camera position by the resection. So I'll read it out and I'll tell you how to get the azimuth. To fix the position of camera station, a ground control is necessary. However, the camera station can be also located by 3-point resection if the position of three prominent points, which may be photographic triangulation stations, are known, and they are also photographed. Now here you can see that this is the photographic plane you will be having, and you will be having 3 different points, A, B and C. So those points I have shown on the photograph. In general it will be like this. See, this is A, B and C. Pictures are taken from station P. Now here you will be having the internal angle as alpha 1 and alpha 2. So these are the horizontal angles. So bearing also you are going to take. If you are using the theodolite also, you can take the bearings, bearings of PA along the line of A, object A, and bearing of along the line B, bearing of along the line C. Those also you are going to record. See how you solve with the theodolite. So same way you can use that concept here also. So you are going to collect the bearings. See, you will be having the angles alpha A and alpha B, right? So get the first angle alpha 1. How you are going to get the difference between the bearing of A and B will be your alpha 1. Similarly, the difference between the bearing of B and C will be your alpha 2. So that I have shown here. Alpha A is equal to alpha 1 is equal to alpha A plus or minus alpha B. Alpha 2 is equal to plus alpha B plus or minus alpha C. As I have said all those things, it will be here. Now the thing is that you have to determine the azimuth, right? Here I have shown the azimuth. Azimuth is the principal plane, or camera azimuth you can call it as. We have azimuth of B. Say you are going to determine the azimuth of B, that equal to when the azimuth of camera or camera azimuth is known, then you can easily determine the azimuth of point B, right? So that is, see that azimuth of B is equal to azimuth of camera plus bearing along the B, that is alpha B. Similarly, azimuth of C, that is also there. Azimuth of C is equal to, I'll show you. Now here you can see that azimuth of C is equal to camera azimuth plus alpha C. Then azimuth of A is equal to camera azimuth minus alpha A plus 360 degree. Now it is going to be changed depending on the location of A, right? Now in general we have azimuth of line is equal to camera azimuth plus bearing, that is alpha, right? Then a small note you should understand, that is, if camera azimuth is required to be determined, then say if you know the azimuth of that particular line or object and you know the bearing of that particular line, then you can easily determine the camera azimuth. Camera azimuth is equal to azimuth of line minus bearing. Now we are going to get the elevation of a point. This is the second derivation, where you are supposed to determine the elevation of a point by photographic measurement. We all know that how to get the elevation of a point by using the theodolite, right? If you say this is the ground and if this is the object, and now if you have kept a tripod here, right, and if you take the bearing, so you can easily determine the height of object, right, by using theodolite or by using even any kind of a level, total station, right? So we see how to determine the top of object by using the photograph. Here you can see this is the object A here, Now you are supposed to determine the height of this A, right? And here you will be having A1, and that same projection will be there to this side, that is A2. Now this A1, it is going to be here. See this, it is going to be presented on the photograph. This is positive, right? So you are getting the same picture there. We don't have negatives here. And then you will be having X. See, this is X, Y, this is X, right? And this is principal point K. Here you will be having, see, the angle between this A1, that we are going to call it as beta, that is vertical angle, and angle between A1, A2, right? So this we are going to call it as what? Alpha, that is horizontal angle. Now here you will be having, see this, F is the distance between OK, focal length, right? Let A be the point whose elevation is to be determined with respect to the camera axis. A1 is the projected projection A on a horizontal plane passing through O, right? This is A's projection. A1 is A's projection. Then now you can see that how it is going to be. How it is going to be by using X and Y. As I say that you can use these coordinates and you can determine the vertical angle. So first we'll see the horizontal angle alpha. Now we can use this X and Y to determine vertical and horizontal angles. First we are going to derive the horizontal angle alpha, that is tan alpha is equal to X divided by F. Now this is very easy. You can see this figure, right? So that is the enlarged figure of previous one. Here you will be having this distance, that is the distance between K to A1, that is X, and the distance between O to K is F. Now by using this figure, see that the distance between A1 and K, that is X, and the distance between O and K is F. So that you can use. Now this is a 90-degree angle here, so you will be having tan alpha. Here you will be having a alpha angle, so that is tan alpha, right? Tan alpha is equal to X divided by F. Now vertical angle beta is, say, that is Y by OA1, right? I'll show you. Now here see this beta is equal to, this angle beta is equal to, that is Y divided by OA1, this distance, right? So that you are going to determine. Now here that is that OA1 is F sec alpha, right? So tan beta is equal to Y divided by F sec alpha. Now you can write that Y by F into cos alpha, or else you can write, now see here, you can write OA1 is equal to square root of F square plus X square, that is F sec alpha. You can write as tan beta is equal to, see, Y divided by square root of F square plus X square. Now from where this square root of F square plus X square came, see here, if you take this is a 90-degree here, right? So this 90-degree you can easily find out this by using Pythagoras theorem here, OA1, right? That is square root of F square plus X square. This is how it is, and by using trigonometric functions, so you can find out OA1, that is F sec alpha, or you can call it as what, whole together, tan beta is equal to Y divided by F cos alpha. Now I'll be using this. I can write that term like this, right? Tan beta is equal to Y divided by square root of F square plus X square. Now if you see this figure, now same way I was saying that, say this is A I want to determine, right, from this A dash on the ground. Then you will be having camera axis or instrument axis there, right? This is instrument axis. Now this is the height above the instrument axis of an object. Now if you take, this is a camera station, then image, how that image is going to be generated on a negative, that is here it is a reverse one, A here and A dash will be at the top. Now this we called as Y, right? And the distance OA1, right, this distance it is going to be square root of, right, this distance it is going to be square root of F square plus X square, right? So that it is there. Now see, by using this figure I'll determine the height. Now from triangle A-OA, this triangle, right, that is, this triangle is similar to this triangle, that is which triangle, OAA1, right? Both are similar triangle. By the properties of similar triangles, you will be having y divided by OA1. Here you will be having AA1 divided by OA1, right? So y divided by OA1, that equals to AA1, we have termed it as V here, right? So that is going to be V divided by OA1. I have shown here where V is equal to AA1, right? So we know that this OA1 is square root of f square plus x square, and OA1, see here, this is O and this is A1, this is D, right? OA1 is equal to D, right? So that I have written there. So that is, if you use these values here, it is going to be, see this, V is equal to D into y divided by square root of x square, f square plus x square. That V is equal to D into y by f, or dy divided by f is f into cos alpha. V is equal to dy divided by f into cos alpha. This is your final formula for V. Now you are going to determine the height. How to determine the height of this object? As I said that if you know the instrument axis or camera axis, right, this camera axis plus V, that will give you the RL of this point, right? Plus you have to add some corrections there. I'll show you how the things will be there, the relation between V and camera axis. Now here you will be having the relation, right? So if the elevation of camera axis, that is instrument axis, is known, the elevation of point can be determined, top of RL can be determined. So this is H you can call it as RL of top of object, right? That equals to HC is elevation of camera lens plus V is the elevation of point above the lens plus C, that is C is correction for, that is curvature and refraction, right? So I have written that where H is elevation of point or RL of top of object, HC is elevation of camera lens, instrument axis, plus V is equal to, that is height of object above the instrument axis, C is the correction, right? So in general you can write, see, RL of top of object, H is equal to RL of instrument axis, HC, height of object V plus corrections, that you can write. Now this is the formula to get the RL of top of object. This formula you have to remember. Now this is the second derivation. Remember, we are having derivation 1 where we determine horizontal and vertical angles. In derivation 2 we have the vertical height. Now by using these two derivations, the one more derivation I am going to do, that is a general derivation for focal length, in next class, and then we'll solve few problems on all these three derivation. Now this is what from my side. I am Professor Balasaheb Jamadar. Thank you.